This is the biggest axial flux motor I own. It's an Emrax 268, which is a 210 kilowatt with it. And I'll need to crack it open today, figure out what's wrong with it. As you can kind of see, there's more of a gap here than there is here, and it also doesn't spin freely, which means the rotor is touching the stator. Here I'm starting off by taking the back side off. Starting off with the resolver, it comes off pretty easily. On the top side, there's a hex key with a split washer in there, so I have to take that out. Now I have to overcome one of the biggest issues. I'm not physically strong enough to get it out of there, and I can't really get like the big side of the Allen key in. So to be able to torque it down, I have to get in there with a big stick, and that finally ends up working, and we're able to get it off. Some sort of locking mechanism here. Looks like I should be able to twist this off, but I'm not too certain how. If I just twist it, maybe it'll work. Looks like it's locked into this tab here. So if I peel that tab down, I should be able to get to it. So that worked. This is a collet wrench. So the nut looks like a collet wrench would actually work really well, but now I just have to clamp it down. I'm doing all this on a welding table since fixturing it's so much easier with a welding table. And that's able to do the trick. It's the locking ring. So now the plan is I want to take the shaft of the resolver out, and to do that I need to like push it through. The best way I think I figured out to do this is kind of clamp down a bearing puller tool and use it to just jam down a lot of force on the shaft. This in here to distribute the force. And yeah, that works pretty well. The shaft is slowly coming out until it finally kind of just pops out. This is the shaft of the resolver. Now I flipped it back over and I'm removing these brass tubes. These brass tubes are primarily for oil flow. Okay, so now I'm gonna go ahead and laser cut a mount for the Emrax to make work holding it a little bit easier for when I take apart the rotor. So I go over to the metal laser cutter and just pop it out. The biggest reason I need this mount is because I want to take off the rotor, and usually I've been just like clamping onto it from the top, but like I can't pull this apart if I was clamping onto it from the top. So I need to clamp onto it from the bottom. And yeah, good old bearing puller trick works again, and we finally get to see the inside of the motor. Now I encounter my next problem. How do I get this aluminum ring off of the bottom rotor? And it's like stuck on. I try angle grinding in a slot for me to get in there with a flathead screwdriver to pry it apart, but that does not work at all. And finally I decided to chisel it, and that kind of works, and then pry it open again with more chiseling and a flathead screwdriver. And now I can get in there and pop it off. And here we can finally see what the issue is. The rotor actually is touching the stator. So it's magnetized together, so I physically cannot move it apart. So here's where I kind of get stuck for a while. I want to disassemble it further, but I don't know. I try a bunch of things, like trying to push the shaft out with an aluminum block and some welding clamps, but that doesn't really work. I try to laser cut another side of the mount, get two of them on there, and try to press it out from the reverse side, kind of like pulling down. And that also doesn't work because I'm pulling on the wrong side. I didn't really understand how the motor kind of was like put together at this point. And then finally, I decided to just jam the shaft out on the arbor press. And then that finally works. So the aluminum core of the motor is epoxied in. So what I'm trying to do here is I'm measuring, first of all, if the aluminum core is a single piece and it goes all the way to the back, or if it's two pieces. If it's one piece, then I can't do anything more. But if it's two pieces, then I can take out one half of the aluminum core. I check the resistance and I find that it is one piece, so I kind of have to figure something else out.
So I could probably pull this out of the bearing seat. Not because it's held in by this flange, which I cannot remove, this aluminum flange. But if I take this rotor out and slide it past the bearing, it might work.
All right, back to the welding clamps. What I'm doing is I'm holding onto the bottom rotor of the axial flux motor and then pushing out the stator with a bunch of welding clamps. And then I jam a bunch of non-magnetically conductive things in there and just yoink it out.
Okay, so it wasn't a bearing, it was just a seal of some sort.
This is a rough model of the axial flux motor. Let's imagine this purple is the stator, the red is the top rotor, and the blue is the bottom rotor, and the orange is the shaft, and then the green is the aluminum shell. Currently, if the issue is that the bottom rotor is touching the stator, for example like this, then that means for whatever reason, there's no gap or the heights are mismatched for whatever reason. It could also mean that the entire thing for whatever reason, the entire thing got shifted up and even possibly the shaft got shifted up. In my case, knowing this now, almost certainly that's what happened, that the shaft got shifted up a bit because the shaft is only constrained by a nut and a press fit. The possible solution path is just to separate it out again by putting shims down in this gap. So that's what I'm gonna go ahead and do. And knowing what I know now, the solution could have been simpler, but this is also a solution that worked, but I lose a bit of efficiency. Okay, so here is the hull. So this is the resolver. It's a magnetic encoder. This is the shaft itself. It seems to be hardened steel, and this is the little nut that you can get off with a collar wrench. This is a really interesting type of like lock washer because you kind of put this on and then you bend up the steel flange to keep it from ever coming off. It's like a very secure type of washer. So this is another like interesting way that they have the resolver connect to the shaft. So there's a diametric magnet at the bottom of this piece of aluminum, and this goes inside the shaft, and when you crank this down, it expands out the aluminum ever so slightly so that it's now like coupled to the inside of the shaft. And that's how you interface with this encoder, with this diametric magnet at the end of this piece of aluminum. So when you spin this, then it knows where it is. And it's a funky like split aluminum thing. This is just an aluminum cap that holds the resolver on. These two brass tubes are used to pump oil through. The two halves of the rotor. This is kind of like the fancy part of the motor, so what makes the motor a motor. This separates the two motors axially and gets them like perfectly aligned, so by height. The interesting thing about this is that the axial distance between the two rotors is constrained solely by this ring and solely by this top rotor. The bottom rotor has no axial constraint whatsoever, so I mean it's good in the sense that there's no like over constraining, but this thing was touching the bottom of the stator. You can tell because there's a little bit of a wear pattern here. There's a little bit of a wear pattern here, which implies that it's touching the stator, which is a no-go. It means that things are not gonna end up well. And that's why I was binding up in the first place. So the vertical alignment of the shaft is extremely critical because it's the difference between your motor binding and it not binding. So honestly, what I think I'm going to do is I'll lose a bit of efficiency if I do this. So what I'm gonna actually do is put tiny shims between here, and putting shims here entirely defines the vertical alignment. So separating them out a bit should fix the issue. But yeah, originally I thought there was gonna be a thrust bearing here, but no, it's literally just a piece of rubber where its sole purpose is to keep things from falling into the motor. Here's a close-up of the other parts. So two bearings. This one is just a normal radial bearing, and then the one down there is a cross roller bearing, I believe, which does both axial and radial constraint. All right, now it's time to put the motor back together. I'm starting off by pressing the shaft in, and it doesn't really want to go in, so just smack it in again. And then I'm reversing the bearing puller trick. I'm starting off by assembling it on the floor so there's nothing magnetic because I really don't want it to magnetize to the steel table. Reversing the setup and just get it on there. There's an important trick I learned is that whenever you're putting the rotor back on, you have to have 3 clamps at 3 points to help you align, so like no one side wants to go down further than the other. And that works here, and it kind of works, but you can kind of still hear it skimming the top. So what I'm doing now is putting shims at the top of the shaft, and that will separate it out by just a tiny bit. separate the top rotor out so that the top rotor no longer touches the stator. And now back to more cut and shims and glue and shims in. Gluing it underneath where the aluminum spacer is going to go. So this does the axial constraint, spacing out the bottom rotor. And then I try to tap it back in, but it's kind of really hard to do because like one edge wants to go in more than the other edge. So 3 clamps gets the job done. Here's a fun thing, just playing around with lenses law a little bit. Induced magnetic field makes it slower. Okay, getting the bottom rotor back on is not the best idea that I've had. Took a look at the Demon core and I was like, yeah, I mean, it will probably work for what I'm doing. So 2 flathead screwdrivers and some clamps and then pry them out, and surprisingly it actually works.
There is no fucking way.
Promising. The stator still spins. Now I just need to lock down the
No.
Woo!
No way.
That's what I'm talking about. Phases of the Emrax hooked up to 3 phases of some skateboard motor.
Definitely move. I mean, that's crazy.
The reason it's so slow is because of pole pair mismatch, right?
Probably.
Okay. Moment of truth. Dude, those are some beautiful waveforms.
Lean sign.
Dude, I can't believe it fully worked. Oh my god.
It's actually crazy.